Welcome to physics online session. In the last class we have discussed the reflection of light by plane and spherical surfaces, and also we have derived a mirror equation. Today we will discuss another important phenomenon of light, that is a refraction of light. So we will discuss what is mean by refraction here. Refraction. So when a beam of light or ray of light incident on a transparent medium, I am taking a transparent medium like a glass, a water, like this. Okay, this is the normal drawn to the surface at the point of incidence. This is the incident ray. Okay, when a ray of light or a beam of light incident on a transparent medium, a part of it will reflects back into the same or original medium, and it is called as reflected ray, and the remaining is transmitted to another medium. This is called a refracted ray. Okay, so what happens to this ray of light here? I am talking about the refracted ray. When light ray travels from one medium to another medium, so it bends. Okay, its direction and speed of light changes at the interface. Okay, this bending or the deviation of light from its original path while passing from one medium to another medium is called a refraction of light. You can see here the definition. So the deviation or bending of light from its original path while passing from one medium to another medium is called the refraction of light. You can see you can see this is the incident ray. So this light is traveling from medium 1 to medium 2. So this is the transparent medium, this is the transparent medium, glass. Okay, one light incident on a transparent medium, so this is part is reflected and part is transmitted, and the transmitted light is called refracted light. Okay, according to the law of reflection, first law of reflection, the angle of incidence is equals to angle of reflection. Okay, that is why both are represented with the same letter, because both are same in magnitude. Okay, we are talking about the angle of refraction, not the reflection, so forget this one. So here if there is no glass medium, so what would be the path of the light? It would be in this path. This is the actual path. This is the actual path of the light ray. But so while it is traveling from one medium to another medium, its path is deviated, a direction is changed. Okay, that is why we can define the refraction as the deviation or bending of light. Light is bending, the deviation or bending of lights from its original path while passing from one medium to another is called as refraction. Okay, so now next we will discuss a laws of refraction similar to laws of reflections. We will discuss laws of refraction here. Okay, now we will discuss laws of refraction here. loss of refraction. Loss of refraction. Once again I will draw the same figure. I am taking a transparent medium on which light incident. So let us take this point as point of incidence, where the light going to strike the interface. So actually it is straight, somewhat deviated, so no, I will remove it, no problem. This is the ray of light incident on the transparent medium, and this is the normal to the surface, normal. So light is traveling from medium 1 to medium 2. Medium N is, let it be air and let it be glass. So and the angle of incidence is I, and it bends like this. This is the refracted ray. This is the incident light ray. Okay. What is the angle of refraction? Angle between the normal and refracted ray is the angle of refraction. Okay. So according to the first law of refraction, according to the first law of refraction, the incident ray and this refracted ray and this normal lie in the same plane, Okay, this is the first law of refraction. The second law gives the relation between the angle of incidence and angle of refraction. Okay, here according to the second law of refraction, the ratio of sine of angle of incidence to sine of angle of refraction is constant. So and mathematically it can be written as sine I by sine R equals to n21 is constant. So this law is called the Snell's law. Okay. He studied the relation between the angle of incidence to angle of refraction when the light is traveling from one medium to another medium. He found that whatever the angle of incidence, so the relation between the ratio of sine of angle of incidence to the sine of angle of refraction is constant, and this constant is called the refractive index, where n21 is the refractive index of second medium, refractive index of second medium with respect to first medium, This is the Snell's law. Okay, here this and it can also be written as n21 is equals to n2 by n1. So this equation number 1 can also be written as sin I by sin r is equals to n2 by n1. This is the another form, and it can also be simplified as n1 sin I is equals to n2 sin r. Okay, this is the Snell's law. Okay, so both the laws are similar to the laws of reflection. Okay, first one represent the angle the relation between the angle of incidence and angle of refraction. The other represents all the three, incident ray, refracted ray and normal, lie in the same plane. These are the laws of refraction. Okay, so the next one, okay, different cases. We'll discuss different cases of refraction of light. For example, light is traveling from a rarer medium to denser medium. And light travels from rarer to denser medium. It bends towards the normal. I'll show here. When light travels from rarer to denser, bends towards the normal. Okay, I'll draw the figure here. I'm taking a transparent medium on which the light is going to incident. This is the transparent medium. This is the medium number 1, air medium. This is the glass medium. This is air and this is the glass medium. So this is the normal drawn to the surface, and this is the incident ray, and this is the actual path of the light ray. But what happens to it? So it bends towards the normal. So this is the angle of incidence, and this is the angle of refraction, and this is the angle between the refracted ray. This is the normal, and this is the angle of deviation. Angle between the refracted ray and actual path of the light ray is called angle of deviation. Okay, so when light is traveling from rarer to denser medium, so here n2 1 is greater than 1 and n2 by n1 is greater than 1. From Snell's law, we can write sin I by sin r is equals to n2 by n1 is greater than 1. So that implies sin I is greater than sin r. Therefore, I is greater than r. Okay. So here I is greater than, when light is traveling from rarer to denser medium, it bends towards the normal, and angle of incidence is more than that of the angle of refraction. Okay, this is the first case. Now what about the angle of deviation here? Therefore angle of deviation delta can be written as, can you write delta here? So this is I, and the total is also equals to I. Why? Because the same two lines. This is the actual path, this is the normal. This angle again I. Okay, this angle again I. That's total angle. How can you write delta? How can you get delta? By removing R from this I, so we will get delta. Therefore delta can be written as I minus, so first I will remove it. Alright, now delta can be written as delta is equals to I minus R. This is the relation for angle of deviation. Next, second one, when light is traveling from denser medium to rarer medium. When light is traveling from denser medium to rarer medium, the light bends away from the normal, okay. I'll draw the figure here. Let us see the same same transparent medium. No, light is traveling from denser medium to rarer medium. So I'm drawing, initially I'm taking the light is in the rarer medium, and it is going to strike the denser surface which is separating the denser and rarer medium. This is a point of incidence. This is the first medium. No, initially the light is in the denser medium. This is a medium 2. This is glass. First medium is glass. Second medium is here air, and the refractive index of glass N1 and refractive index of air N2, and this is the incident ray, and this is the normal, and this is the actual path of the light ray. This is actual path of the light ray. So what happens when light travels from denser to normal? It bends away from the normal. It is in the previous case it was bending towards a normal. No, it bends away from the normal. No, it is the refracted ray. So what is this? I'll change the pen here. This is angle of incidence, and where is the refracted ray? This is the refracted ray, and where is the normal? This is the normal. So the total is the angle of refractions, but the angle between the deviated ray or refracted ray and actual path is called angle of deviation. Okay, so in this case we can write n21 is less than 1 and n2 by n1 less than 1, and from Snell's law sin I by sin r is equals to n2 by n1 is less than 1. So therefore I is less than r. Okay, so angle of incidence is less than angle of refraction. So you can easily say from this figure. And what about the relation? So delta is equals to, for angle of deviation, delta can be written as, so delta by subtracting I from total r, so we will get delta, angle of deviation. So r minus I gives us the angle of deviation. Look at the previous expression. So here it is, the previous case, when light travels from rarer to denser, angle of incidence is greater than angle of refraction. So an angle of deviation like this. In this figure, when light travels from denser to rarer, since the angle of incidence is less than angle of refraction, so it bends away from the normal, and this is a relation for angle of deviation. And the next third case, third one, if the refractive indices of two media, refractive indices of two media are same, then what happens? Look at the figure. I'm taking the same transparent medium. Okay, this is the normal. This is the first medium, second medium. First medium is air, now it is glass. So light is traveling from rarer to denser, but the refractive index, sorry, I said wrong. So I'm taking refractive index of two media same, so I'm not specifying the medium here. Okay, here medium 1 whose refractive index is n, and now n2 refractive index of both the media are having same refractive index. Glass and glycerin almost nearly same refractive index, so I'm not mentioning the medium here. So, and first medium refractive index n, second medium also having the same refractive index, then what happens to the ray of light? So this is the ray of light incident on the boundary separating two media of two media having same refractive index. So light does not deviate from its actual path. If the refractive indices of two media are same, light does not deviate from its actual path. Okay, so in this case change the pen here, and n2, sorry, in this case n2 1 is equals to 1, it implies n2 by n1 is equals to 1. Therefore, according to Snell's law, sin I by sin r is equals to n2 by n1 is equals to 1. Therefore, I is equals to r. And what about the deviation? It is not deviating, so the angle of deviation is 0 in this case. Okay, this is the third case, and the last one is fourth case. If light incidence along the normal, fourth case is normal incidence, normal incidence. Let us take the same medium, okay, so medium 1, medium 2, now I'm taking air and glass, no problem. Now air and glass, if the light incident along the normal, so this is called normal incidence. For normal incident, angle of incidence is 0. Why? Because the incident ray is along the normal. Okay, incident ray is along the normal, so the angle of incidence is 0. So what about the refracted ray? It does not deviate from its actual path. It goes straight. Refracted ray also travels in the same direction. This is the incident ray and this is the refracted ray, both are along the normal, so therefore angle of refraction also 0. Therefore angle of incidence is equals to angle of refraction is 0. Okay, angle of deviation also 0 here. Okay, these are the 4 different cases. So what is happening, we have discussed in these 4 cases, we have discussed what happens to the ray of light while traveling from one medium to another medium. Okay, the first case is light is traveling from rarer to denser medium, it bends towards the normal. When light travels from denser to rarer medium, it bends away from the normal. And when if the light is traveling between two media of same refractive index, it does not deviate from its actual path. If the light strikes the trans medium interface along the normal, also it does not deviate from its actual path. Okay, the next one is, I'll express here, we can write n21. What is n21? Refractive index of second medium with respect to first medium. N21 can be written as n2 by n1. Okay, and n12 can be written as refractive index of first medium with respect to second medium. It can be written n1 by n2. Therefore we can say that n21 is equals to 1 by n12. Okay, in place of n21 we can write 1 by n12. Okay, the next one, okay, here what is the refractive index? Or before that I want to define what is the refractive index. So before that I want to write one more expression here. What is the refractive index of third medium? Refractive index of medium, refractive index of medium 3 with respect to medium 1 can be written as medium 2 can be written as n32, and it can be written as n3 by n2. That I want to rewrite this expression as n3 by n1 into n1 by n2. So if you cancel this, so you can get, so we can write like this. Okay, why I am writing like this, you can see now. So n32 can be written as n3 by n1 can be written as n31, n1 by n2 can be written as n12. So n32 can be written as n1. Refractive index of third medium with respect to second medium can be represented in terms of refractive index of third medium with respect to first, and refractive index of first medium with respect to second. Okay, so these are the different relations. Okay. The next one is, what is the refractive index? How can you define refractive index? Mathematical. Actually it is the characteristic property of the medium. Refractive index is the characteristic property of the medium. First I will discuss what is the absolute refractive index. Absolute refractive index represented with n. Okay, so it is refractive index, it is the ratio of speed of light in vacuum, to speed of light in a medium. Okay, that can be written as mathematically n is equals to speed of light in vacuum represented by c and speed of light in medium represented by v. So this is a general expression of absolute refractive index of any medium, absolute refractive index c by v. Okay, now here the second one, relative refractive index, second quantity, relative refractive index. relative refractive index represented by n12 or n21 like this. Okay, the relative refractive index is nothing but the refractive index of one medium with respect to another, or refractive index of one medium with respect to relative to another is called relative refractive index. Okay, so it is represented for I am taking for a suppose n12 is the refractive index of first medium with respect to second medium. So n12 is the refractive index of first medium with respect to second medium, can be written as n1 by n2. Okay, this is the relative refractive index. Okay, now and it can be written as so n1 by n2 is equals to n1. What is n1? From absolute refractive index we can write n1 as n1 equals to c is constant, and n1 nothing but v1. v1 is the speed of light in medium 1 whose refractive index is n1. So we can write it as c by v1 whole divided by n2 can be written as c by v2. Therefore it can also be written as v2 by v1, another ratio, another expression for refractive index. Okay, and we know that v is equals, from the previous chapter we know there is a relation between the speed of light, frequency and wavelength. So therefore v equals to for in a vacuum c equals to nu lambda, and in a medium speed of light can be written as nu into lambda. Okay, here v1, from this expression v1 can be written as v1 is equal to frequency of light remains constant, it depends on the source, so it is constant. So for the in the first medium v1 equals to nu lambda 1, frequency is constant, it depends on the source not on the medium. So therefore v1 it is okay now. Next v2 is equals to nu lambda 2. By substituting these relations in the previous expression we will get v2 by v1 is equals to lambda 2 by lambda 1. Therefore what is the relation for different relations for refractive index, relative refractive index? So n1 by n2 is equals to v2 by v1 is equals to lambda 2 by lambda 1. Okay, these are the different relations for relative refractive index. Next, how can you write n1 to n2 how can you write expression for n21? n21 can be written as n2 by n1. Similarly we can derive as v1 by v2 now. Okay, inverse relation between the refractive index and speed, that is equals to lambda 1 by lambda 2. Okay, these are the different relations. The next one, what are the refractive indices values of different medium? Refractive indices of different media. So I am taking a few example here. For air refractive index as equals to, so all the refractive index are compared to vacuum, so absolute refractive indices, so with respect to vacuum, so n is equals to, for air refractive index of air is equals to 1.0003. okay, for ice refractive index of ice is equals to 1.31, and refractive index of water is about refractive index of water is about 1.33, and refractive index of kerosene it is about 1.44, and refractive index of turpentine oil, it is about 1.47, and refractive index of benzene it is about 1.50, and crown glass, there are two different glasses, crown glass and dense flint glass. Crown glass and dense flint glass refractive indices are 1.52, and this is a glass, this is also glass, but dense flint glass 1.62, and for diamond it is about 2.4. These are the refractive indices values of different media. Try to remember only very few. So this is nearly, will take it as 1, refractive index of air nearly 1. Try to remember for water it is 1.33, and crown glass it is 1.52. These are the important refractive indices values. Okay, so what is the difference between the optical density and mass density? What is meant by density of the medium? So before that, I want to discuss few points here. What about how can you decide the medium is rarer or denser medium? By its refractive index value. Okay, so the medium with low refractive index, low n nothing but low refractive index value, is known as a rarer medium. Similarly, the medium with high refractive index, high n, it is said to be denser medium. And what about the speed? The speed of light is more in a rarer medium and less in denser medium. Try to remember these points. Okay, the next we will discuss the relation between mass density and optical density. Okay, so mass density, what is mass density? Mass density, it is the ratio of mass to volume, or mass per unit volume. Mass per unit volume is called as mass density, represented by rho. Okay, mass density, it is a mass density. Now what is optical density? Okay, so it is mathematically defined. Actually it is the ratio of speed of light in vacuum to speed of light in medium. Okay, it is the ratio of speeds. So what is the mass density? It is the ratio of mass to volume ratio. It is completely different from mass density. Okay, so here so let us see one example of let me see one example of a medium which has optically denser medium, so whose mass density, so mass density of optically denser medium is less than that optically rarer medium. Let us take one example, turpentine oil. and water. I am taking two medium here. Okay, so mass density, when you compare the mass density, so water is denser and oil is rarer medium compared to the mass density. When consider the mass densities, so mass density of water is more than the turpentine, but what is the refractive indices of turpentine? It is about 1.47, and for water it is about 1.33. okay, so it is mass density of water is more, but it is optically rarer medium. Mass density of turpentine is low, but it is optically denser medium compared to water. Why? Because it has more value of refractive index. Okay, so this is about the refraction of light, and in the next class we will discuss the natural consequences of refraction. Okay.